Hello, everyone. Thank you for your time today. My name is Edgar de los Santos. I am a structural engineer and I am the user and development lead at Midasoft. I've been with Midas for 11 years now, and I also have bridge design experience. If you have any questions during the course of this presentation, please feel free to ask in the chat box. Towards the end, I'll be answering your questions. Today, we're going to talk about how we at Midas are going to upgrade our products and services with the Midas collection. This will be the flow of today's agenda. First of all, I'll give you a brief introduction of what the M collection is. Then I'll talk about the improvements of Midas Civil with the Civil NX. Then I'll provide you an introduction of CIM, our answer to information modeling in bridges. Then I'll give you a brief intro of FENX and I'll end up with the reinvented services. During the course of this presentation, you're gonna see a QR code at the top right corner. This QR code, you can use it for, you can fill out a short form and we'll reach out if you have any additional questions or if you want more information about the uh, programs that we're launching today. Basically, just put your name in the form and we'll be able to contact you right away. During the course of the presentation, this QR code will be at the top right, so please feel free to scan it whenever uh, you want. We at Midas always strive for the best and the latest innovation in our technology, and today's event marks the beginning of a massive shift. This shift includes three essential values redefined: the new upgrade to Civil with Civil NX, the integrated bridge package M collection, and finally the upgrade to our services. Let's talk about M collection. M collection comprises these four tools: MIDAS Civil NX, which, as you all know, needs no introduction, for its global modeling as well as analysis and design capabilities for bridge projects. We also have CIM, which is basically a tool for preliminary infrastructure information modeling. Using templates, you could quickly obtain the quantities, estimates, and drawings, and so on. Similarly, we have MIDAS CAD Infra Design, which is a CAD tool geared for infrastructure projects, as opposed to most products in the market which have features for architects and buildings. As for FEANX, which is our nonlinear detail analysis tool, we are also making it available for the M collection package. The major difference as compared to other software packages is that M collection is not a set of independent software. They're highly compatible for data transfer. So now you have the freedom of how you could go about your work. You can start in any environment that you are comfortable with and transfer the data seamlessly to other tools. You can start with Excel and export the information from Civil NX or CIM and further take it to FENX if it's required. Or you can start directly with Civil as usual and export the information to other tools. Since our industry is rapidly changing and now clients are requiring higher level of detail, information models, and so on, we have developed this set of tools that would allow for easy interoperability, robust and powerful capabilities with a world-leading and reliable technical support. In fact, we're not just limiting ourselves to working in the MIDAS environment. There may be already some tools that engineers are familiar with. So now, if you use M collection package, you can also use CIM or Civil NX as a hub to support the integration with various 3D BIM tools or local design programs for each region. As you see on the screen, multiple programs that are already part of our industry can be utilized to interoperate between MIDAS and M collection and these tools. Okay, let's talk about the improvements of Civil NX. One of the biggest improvements is API, but even except that, we have improved Civil for engineers who are happy with the user interface as well as the different capabilities of the program. Let's look into these changes. Now we have adopted dark mode in line with the latest trends in our graphical user interface. We have made a wider workspace by allowing command window to be folded. We have improved our icons. No more hide and seek with the icons. We have changed all the icons, made them available easily, and you can use any type of resolution for your screen. Moreover, for big models, the word stream may become too big, and it is a bit inconvenient to scroll and find the required inputs. That's why we have added a search bar within the work tree to quickly go to the required input and modify it if required. Now, colors can also be assigned on structure groups. This makes it very easy for visualizing and inspecting the right elements are assigned to the right groups. Based on the feedback for Civil, we have realized that we need to include transparency to improve the usability. By setting the component to transparent, engineers can now visually confirm the presence of tendons within the components, and this will reduce the engineering errors. The analysis window is also revised to easily verify the progress of each analysis. The analysis results are displayed in a hidden form in the command line at the bottom, and a pop-up messages appear as you see here during the execution. If there's an issue with the model or warning, the program can easily, by clicking on the error, show you where the exact location of the error is. This will save you time in the process of reviewing your model or debugging it by you quickly going to a specific location. Now let's talk a bit about the modeling features of Civil NX. MIDAS Civil has wizard-based modeling features that allow you to define or create different types of projects, from the very basic beam column arch structures to the most advanced applications such as segmental suspension and cable bridges. There are multiple structure wizards that range from PSC, steel composite girders. With these wizards, you'll be able to create the loads, layouts, as well as the tendon arrangements and the construction sequencing. Also, Civil NX has structure wizards for cable bridges, which allow you to create suspension as well as cable stayed projects. For more specialized analysis tools, we have the transverse model for the grillages, as you see on the screen. If you need to analyze a transverse section, the program has functionalities to create a transverse model with the loading for easy analysis of the flanges. One of the key features of Civil NX is its rail structure interaction model. It provides automatic modeling that can perform the rail track analysis considering the rail interaction. It's a special analysis for road bridges and allows you to create the braking forces as well as the acceleration forces with different types of result displays that will allow you to quickly review the stresses on the models. Now, going into the analysis features of Civil NX, you'll be able to see that the program has a wide variety of analysis types, ranging from dynamic to large displacements analysis, geometric nonlinear analysis, and so on. Some of these key features are the moving load analysis, which allows you to create based on different types of codes, different trucks, or you can even define your own truck for your analysis. One of the key features of Civil NX is also the construction stage analysis. As you know, clients are getting more strict and about how the construction sequences go in the project. You can do construction by stage girder erection and also the deck pouring sequence within the program. No need for multiple models. You can do everything and review each one of the stages within the Civil NX. Nonlinear analysis is also available in Civil NX, where you have pushover, the nonlinear static analysis for performance based design can be quickly generated in the program, as well as nonlinear boundary conditions, which includes different types of isolators and numbers. Okay, these are some of the changes of Civil NX cosmetics. Now let's talk about performance. The post-processing can now be up to 20 times faster. You can generate analysis results and reports faster than ever. Let's take a look. Let's say we are comparing the concurrent forces output for this model in Civil and Civil NX. So in Civil NX, it will take just about, let's say, a minute to extract the tables for the post-processing of this type of project, as compared to the older version of Civil, which takes about 23 minutes to extract the results. You have a program that is very powerful because it can handle different types of bridges and analysis, and also a post-processing mode that will allow you to quickly extract the information. Next is the in-app search feature. You can find all you need in one place. Yeah, we've always had the online help manual, but still it needed to be accessed out of the software. And it was a bit inconvenient to find applications for those features. So now we have added this in-app feature that will allow you to search functions. You can find manuals, tutorials, FAQs directly within the program without the need to look somewhere else. Just like that, if you click on any of the documents, a window will simply open showing you the details about the specific function that you checked. Okay, we're done with the small changes. Now the big one, which is the API. And one of the biggest benefit of API is the design automation. Yes, MIDAS Civil has design capabilities, but with the Civil and Next API, you can link the design sheets with your model files for seamless data exchange. In fact, you can make your own design sheet so versatile that you may not even need to open MIDAS Civil. The level of automation is now completely in your control. Let's take a look. One of the features that we have added is an Excel API. Let's say you have an Excel template which was generated for a PSCI girder, which is shown on the screen. You simply link the Excel with MIDAS Civil via a MAPI key. And just by you entering some preliminary input, you can easily generate a model, along with the construction sequencing, as well as the static and moving loads. Moreover, I'd like to mention here that you don't even have to have the Excel and Civil on the same system. You can have Civil on on a certain more powerful workstation, and you can work on Excel with your basic laptop. As you can see, you can create a model. You can also run the analysis from Excel. And then from there, you can extract all the result tables directly from your Excel sheet. This will save you time and also um, allow you for less, reducing the amount of errors in the process of extracting the information because it does it directly from your model with the connected MAPI key. Aside from the tables, you can also get result diagrams and different images from the program. As you see, you can quickly bring your different result diagrams and customize these sheets for your own deliverables. My colleague me here, Jane, is going to show you a little bit about this later on during the demo session. Excel add-in enables users to create Excel templates directly without the need for coding knowledge. By combining the various features and capabilities offered by Excel, you can build your own design automation system tailored to your specific needs. We have added this add-in. It's called mConnector. I'll show you a little bit about it. You can simply search this add-in in Excel. Once you install it, you just log in to the program by using this connect function. You log into your MIDAS profile, and you can quickly connect your MAPI key with your Excel. After it's connected, you can bring your result tables directly using the Excel. This is just to show you. Let's say you are looking at the reactions for this model and you want to create a dynamic report table from there. You can also store different images, let's say for the 3D model, and you can bring that information directly to your Excel sheets. No more need for copy pasting. You can simply tell the program where do you want the tables to be brought, and you can automatically connect it, the exact same results. The same thing you can do for the images. So let's say you want to bring the result images to this location. The program will automatically extract it from there. Again, the Excel does not need to be on the same system as MIDAS Civil. This makes it very easy for you to monitor and extract required data from a workstation anywhere. Again, all of the results are customized, so you can create the sheet that you want with the information that you want. Next is the plugins. We'll be launching a marketplace and regularly update the plugins here for the use of engineers. In fact, you can also generate such plugins using JS and deploying it for your personal use. Or you can also deploy it for your company or even launch it globally utilizing this marketplace. Or you can also use the search features to find any plugins that we have available. With this development, you don't need to wait for us to develop any localized code. We will continue to develop it, but it gives you tools to deploy certain automations within your organization as soon as you guys have a need to do that. My colleague Mihir is also going to go over some of these plugins later on. And also we have, for engineers who are proficient with coding, they can utilize languages like Python to build design processes using APIs. This is an example that demonstrates the use of Python to optimize the size of a simply supported RC beam. It takes into account the depth of the section and also the stresses um, for that particular section. After running the analysis, the program checks the stress values. If it's not within the stress values, it increases by a certain number. It does recheck and it continues to increase it up until the stress values are marked. Then from there, you can utilize these features for, let's say, value engineering. As you see, the final depth in this case is 550 millimeters with the stress values. You can use it for value engineering. You can use it for um, research and development. You can also utilize it for your own more economical sections as well. Again, this is a Python coding, and this is just an example, but you have a broad uh, utilization options for there. As a last feature of the API, I like to demonstrate parametric modeling and modification using the popular tool, which is Grasshopper. Let's say you have an existing detailed design model in Civil. You can create a simple script linking the curve in Rhino to existing model. You can modify the curve with simple clicks, and immediately the model along with the loads, pre-stressing, etc. will be updated to the new layout as you see on the screen. This can be an extremely helpful feature in situations where you may need to quickly do a preliminary design output for bidding in new projects. You can quickly have your base model and then recreate different bridges from there. Okay, now let's talk about CIM, our answer to information modeling for infrastructure projects. Usually when we talk about information modeling in our industry, these are the outputs that come to my head. Visualization for exact placement at site with the execution process, clash checking for reinforcement, and render views for better understanding at the client's end. There are some mandatory information modeling requirements by many DOTs and government organizations, and this is why we have created this package. In most situations, us as structural engineers have a burden to deliver this level of information. We want to change this environment and we want to provide with information modeling output that the client wants. At the same time, we reduce the burden on structural engineers. That's one of the strengths of CIM. Let's consider this example. This is an arch bridge with a 3D arch alignment. In also has a profile and face. This arch is connected via tie beams. 3D information, stiffeners, everything inside will make it very complicated to obtain drawings or create the drawings based out of it. With the use of CIM, you can quickly create drawings with the level of details that show the stiffener. You can use the program to create different offsets, angles for the stiffeners. CIM can be used to ease the difficulties faced by the structural engineers. Earlier, we talked about parametric modeling and modification using Grasshopper. However, if you don't have Grasshopper or don't want to code, but still need parametric model, you can use CIM for that. You can just generate a straight unique template and you can assign that template to any layout. Let's take a look. This is just a small demo that shows how you can assign the cable stayed bridge using a specific layout. You select the layout and you can add it to your project. From there, you can preview it. And as you see, the program can quickly create a curve layout, and the cable locations as well as the pylon orientations are automatically updated. This comes in very handy when we talk about the drawings. Now let's jump into a little bit how the interaction of CIM and CAD. Let's say that you have this model in CIM. The only essential difference is that MIDAS CAD has an extra layer of model information, which is the 2D drawings, generated based on the 3D models. As you can see in the video, you can open MIDAS CAD, send the information directly from the CIM, and extract different types of drawings in 2 dimensions. Let's say for this cable stayed bridge, you can simply create annotations for the coordinate systems of each one of your cables. If your layout is updated in CIM, these annotations will also be updated in CAD. There's no need for you to redo all this labeling. And as you see, this could save you a lot of time if there's any modification during the design or during construction of your project. The spatial coordinates at the anchor points of the cables, as you see, are the actual spatial coordinates after considering the changes of the horizontal alignment and vertical alignment. These are the key technical parameters in a bridge design, construction, and manufacturing, and you can quickly extract the information utilizing MIDAS collection. You will have a specialized function base for traditional bridge design concept. Let's say on the left side, you have a precast girder arrangement function in which you can quickly create straight girders based out of a curve alignment, as you see. You can quickly arrange your girders as shown in the video. You can also create automatic function for variable height of girders, and you can also utilize it for tendon design functionalities. Let's talk a little bit about our final tool, which is FEA-NX. FEA-NX is a detailed finite element analysis tool that has tremendous capabilities. It could be deployed for detailed substructure interaction, or if you like to check joint fatigue. Similarly, if you need to consider nonlinearity, like contact or interface and concrete cracking, FEA-NX can be utilized. The program can also be used for geotechnical applications. Let's say that you have a bridge, you want to analyze the soil, or you are part of the tunneling group of a firm, or you can run the typical dynamic seed pitch slope stability analysis, all within the MIDAS collection. Let's take a look at a project application, which is a metro station that has 6 steel beams connected to a node in Civil NX. Now, usually we are satisfied if all the elements are structurally safe. However, we also need to verify whether such joint is practically possible or not. So for this, the highlighted region was selected and explored in a 3D geometry. You can send the information to, let's say, CAD or FENX. You can mesh in FENX and then send it back to Civil. This is a very simple step that you can utilize. You mesh it, you send it back, and then you can reanalyze the entire connection. From there, you'll be able to see whether or not this connection is possible. This is a data transfer that can be done very smoothly and also is within the MIDAS environment, so you can do it very quickly and also with the exact same location of coordinate system of your nodes. Third is the last chapter, which is the reinvented services. Any tool is only as good as the engineer who uses it, and we can't expect an engineer to learn everything without any reference. Hence, we have launched an Academy website with detailed theoretical and modeling references for a variety of structures. Within the MIDAS Academy, you can check the progress in each course as well as your engineers. As part of our services, we have created the MIDAS account manager function. License managers can easily check the status quo of MIDAS licenses, such as who is using which license, and also they can obtain a service dashboard which shows everything regarding the usage of the programs. Statistics, comparisons for previous years, and so on, as you see on your screen. These have been the major upcoming new values of MIDAS. The Civil NX, which is our revamped structural analysis program for bridges. M Collection, which is our package that includes the bridge information modeling, CAD, detailed nonlinear analysis, and Civil NX, and our reinvented services to boost your experience with our expedite and reliable technical support. I'm going to pass it along to my colleague Mihir Jain, who is going to do a demonstration on the different functionalities that we saw for Civil NX. Thank you very much.
All right. Thank you, Edgar. So, good afternoon, everyone. I'm Mihir Jain. I'm technical support engineer at MIDAS Soft, and I've been with MIDAS since 4 years. Before that, I've graduated in civil engineering and did my master's in structural dynamics. In this session, I'll be presenting MIDAS Civil NX to you all. So, again, thank you for joining us today, and let's get started. So, as you can see in my screen, this is the new Civil NX program, which is an upgrade to MIDAS Civil. It is having all the features present in Civil along with major update of API integration and user interface upgradation. To start with, we will first understand about the plugin application shown by Edgar. So for that, we go to this apps tab and here you will find this plugin feature. So we just click on that option and these plugins are present in marketplace as you can see, and each plugin is made to serve as a solution to corresponding problem. For example, here you can see a plugin for group pile, which is meant to be used when we are making some substructure like pile or the pile cap. So if you remember earlier, we used to do that manually with the node and element tab, But now since we have this plugin, it will be really easy to model it. So you can understand plugins as a way to overcome any limitations of the program using API. And these plugins can be made by any individual or company and can be used internally or released in the similar manner in the marketplace for all. The main purpose of the plugin development is to help every individual to experience the benefits of API even if they don't have much exposure to the same. So to start with, we will first use this alignment generator plugin, and I just click on that option. So when we select a plugin, a page is loaded, which is having all the features of the specific plugin that has been selected. So you will get the details over here and a video correspondingly to show how to use that plugin. Now, once we start the plugin, here you can see like I'm having two tabs of alignment and segments. I will add number of alignment that I have to define, and same thing for the segments. Here I will give the length of each segment. So in this case, my segment first and third is of length 60 feet, while the medium or the intermediate one is of 30. Then here you can see like the material ID and section ID has been used and assigned for these segments. Coming to the alignment portion, again we will first set the length, and then the intermediate profile that I'm having is of clothoid curve, which is having radius of minus 60 and plus 60. Once you input all the details, here you can see like your profile has been made for the bridge. So this is the actual geometry, and we can click on create to get the model ready. I just close the plugin. So here you can see we have a PAC box section having alignment in this manner. From here I can set the viewing angle. Now in case I want to add the peer section as well on this, so I will just select the nodes from which I can create the peer section. After selecting it, we will just go to the node and element and use this create element option. So here I can just give the details. Before that, I will choose the extrude element option present. Once I select that, I can choose the material and the section that I want to give. So I'll be using peer section, and my distance is 10 at the rate minus 3. I give that and I click on apply. So you can see how easily you can define any element from any node. Moving forward, as I talked about group pile plugin, which is used to make some substructure details as well. So in this case as well, if I want to make the pile cap and the pile, I will be using that plugin feature. So we go back to the marketplace. And here I have the group pile plugin. I just select that and I click run. I will be defining some structure group as well that will be used in the plugin feature. And again a boundary group. Once I define that, I'll just refresh it so that these options are available in my plugin for the definition. And now I just select the substructure group as the structure and the boundary group. Then I give the material for my pile and I will choose the pile section, which I've already defined. In case I want to use pile cap as well, like in this case, I will check on this option and again I will choose the section for pile cap. Here I will give the starting of these node number. So I give 300 and 200 over here. Then I choose the array of pile. In this case, I'm having 3 cross 3. So I just select that. I choose the spacing between them and the cap edge. When I give the pile length, in this case, I'm giving it as 20 feet and pile height as 3, like pile cap height. Once that is given, we just have to select the node from which you want to initiate this creation of pile group. You get all the details and I click create. So here you can see, like with a single input, we were able to model these number of elements and the substructure portion. Similarly, I will do that for this node as well. I'll just select the node. Now you can see like it has been completed. After that, I just close it. So you can see like within a span of 5 to 10 minutes, you will be able to model something like this easily, even though it is a finite element modeling, but it is really user friendly, I would say. Moving forward to some load definition. So as you might already aware, like MIDAS will perform moving load analysis on influence approach, like influence line diagram approach. In this case, we have also added a series load generator where a train load is set for your moving load, and it is basically a set of static load that is running across your whole bridge within an incremental value of distance. So for that, we go to this plugin option and I use the plugin series load. This feature will help us to get the concurrent results as well for the worst critical combination of the moving load case. So basically I can choose the vehicle type over here and it has the details of loading and the distances. Then I can give any additional distributed load, or even in case you want to have any new vehicle load, you can just easily define it over here and perform the analysis for that. So if in case you want to consider centrifugal force, you can check on that option, or I can check off for now. Then I give the total number of load cases that are to be considered and distance of series load, like what is the incremental value of these loads. Once given that, we will select the section for our superstructure. So that is selected and I click apply series load. So you can see elements has been successfully selected. And now if you go to check the work menu, here you can see all the static loads has been defined and the details has been provided. Once it is done, to check how your load is running across the bridge, you can click on the show series load. So it will show you the point of application and also the intensity of these loads. Another thing that is an upgrade to user interface, as already mentioned, is this scroll option that you can see here, like how the values are enlarging and the position of the vehicle is changing. From here, I can display the loads as well. So this was an example to show how plugins can be really useful for your day-to-day modeling or some specific limitation that came across during your modeling part. So now we will move towards the next part and we will talk about steel composite bridge. So we will be taking this example to understand the modeling from Civil NX in a basic manner, like from scratch. And here we will be taking an example of steel composite bridge. Before we start, let's have a quick comparison to the user interface of Civil NX from old Civil. So as you can see, these modeling tabs are arranged in the linear manner itself that was present in MIDAS Civil as well. So basically we follow the same approach, like we start with the definition from material section properties. We deal with the geometry of the bridge, then boundary, loading, analysis, results, and then the design and load rating part. On left is the work menu, and the message window has been minimized in this manner, like you can always enlarge in this fashion. Apart from that, in the work menu, the most important feature as an add-in is like the search option. So in case you are having a lot of details of your bridge, you might know or you might be aware of MIDAS Civil, like you can just select and control your model from this work menu. So in the similar manner, now the search option is present. So it is really easy to select anything from the work menu. Then the scroll option I already shared, like how does it work. So to start with, first I'll set the units to kips and feet over here. And then we start with the definitions of material and section properties. So as before, you can easily add any material Just select the type of material, choose from the code in the library, and you have the material like this. I click on OK and the material is defined. Apart from that, another option that I'm having is to import from any other program. So in case you are already having some model which is having similar type of material or sections, or in case you work on similar type of bridges, so it is really easy to import any material or sections that are predefined. So I'm just doing that. So my material and sections are imported. Then for the next part of the geometry of the bridge, we go to the structure tab and use the steel composite bridge wizard. So wizard is a place where we give all the inputs in the text-based format. And the good thing is like you can open any existing saved wizard file. So it has all the details and you don't have to worry about each input one by one. Here you will find 4 tabs, that is layout, section, load and construction stage. And I will be giving the details for each one by one. First, you have the option to choose what type of section you are having, whether it is steel, eye, box or tip section. Then you have the option to choose the modeling type. Since MIDAS Civil NX is a finite element program, you have the liberty to choose what elements you want to use. It can be all frame, all plate, deck as plate, girder as frame, or deck and web as plate and flanges as frame. Then I've given the span information. In this case, I'm having two span of 120 feet. In case there is some additional span, we can give it in this manner. Then we give the deck width. From here, you can consider the skew angle and radius as well. And since MIDAS is all-in-one modeling approach, so you have the liberty to define your substructure as well inside the wizard itself. So here we are giving the details for the pier cap and the pier. And for the substructure like the foundation part where you are having pile or the pile cap. So as I already showed in the previous example, earlier that has to be done manually. But now you can use the wizard to model it till this part. And then you can use the plugin option to deal with your foundation as well. So we just give the details of substructure. We move towards the next part, that is section. Here you can see the transverse layout of my bridge is being set. So from the center of the bridge, I'm giving the distances for each girder. In this case, I'm having 5 girders. So the central girder will be girder number 3, which is having offset of 0. And each girder are spaced at 8 feet interval. Hence -8, -16 on the left side, as the sign convention is negative, while on the right it is positive. Once you provide that, here you give the material for your deck girder bracing. Then you can also choose the configuration of bracing from this feature itself. You can choose whether the top and bottom chord are present and what kind of bracing you are having, whether it is XV or inverted. Then you give the girder section and we move towards the next tab, that is load. So here I am setting the layout, like what are the details of my crash barrier, median strip and the total width of the carriageway. Once that is done, here I can choose the static loads and then I have the liberty to choose the moving load definition from here. So I select that. You will find different codes like ASTO standard, LRFT, PennDOT or Canadian standard. So we will be using ASTO LRFT first in this case. I select that and I will check on this live load option. Then I go to this define traffic lane. So in this case, I'm having 3 lanes since my total width of 36 feet. So we are having each lane of 12 feet width. And here you can see these are spaced at 12 feet interval. So we are giving the offset from the extreme left portion of the bridge to the center of these lanes. This is one way to define the lanes. Another approach is like you can just give the total width of your carriageway and the program will automatically select the number of lanes to be set on that width using the formula. And apart from that, it will position the vehicle in all the transverse possible placement. So that will give you the most critical effect in the transverse behavior as well. Then we choose the vehicles. So in this case, as you select the Astro LRFD code, you will have the standard vehicles corresponding to the same. I'm choosing HL93 truck and I give the dynamic load allowance for the same. I click OK. As you can see, we have all the legal and permit loading as well, and also the different specific TOT vehicle. Even in case your vehicle is not present in the library, you can always use this add user define option to give any vehicular load. And you can also perform the load rating for the same. Once you are done with it, you move towards the next part, that is construction stage. So here I'm just giving the details of the stages. I'll talk more about it once we generate the model. So as of now, we have completed all the details. I just click on OK and the program generate the model for me in this manner. You have the option to see the program model in all the possible ways. And from here, you can just control the viewing angle. So basically, if I want to see through X axis, I will choose the global Y and global Z. That is the top. So that is how you can select the viewing angle, and this is the isometric view. I will check on the nodes like that. Now coming to the stages, so here you can just go and select the different stages. Like stage 1 substructure is activated, then the girder bracing. Stage 3 one you don't see any change here, but if I just search for wet concrete load here, I right click and click display. So this is the search menu that I was talking about. Now you can just navigate and search the option and it will work easily for you. I want to undisplay as well. Next stage, you see the casting of the deck has been completed. So basically, stage 3-1 was the place where the wet concrete load was applied to add the casting of your deck, and then it has gained its strength. The formwork is removed. It contributes to the stiffness and the model. And stage 5, if you go to the stages, you will find it is having duration of 10,000 days. So all your time dependent functions, be it creep, shrinkage, when you define those features, it will be incorporated using this time gap. Now, after you have completed all these things, you can just go and select this work menu as well to understand like we are having what elements, material sections. And it is quite easy to select any element like this and you can activate in this manner. I can activate all as well using this tab. So these are again also like made available directly in the working region of the modeler. So it becomes quite easy to select and navigate. I can also activate in this format. In case you want to make any changes to any of the sections, you can just select it in this manner and I will just drag and drop in this. So you can see in the command window, like I can make the change to the base stage. So I just go to the base stage and then I update this, say with the peer cap section. So you can see the update has been made. From here, I can undo the program. Once you are done with this part, like you have analyzed your model and understand all the details, you go to the load part and I will be defining the moving load case. So I select moving load and the case over here and I click add. You can see now the dark theme is also available as the display, another upgrade to our user interface. I just give the name and I click add. I select all the lanes and give the minimum lanes and maximum lanes as 1 and 3 to be loaded. So this means the program will create the configuration of each lane loaded single individually or like in the combination of the others. So we have given the moving load case and now we will just perform the analysis. So after performing the analysis, we go back to the like post-processing mode and from here we can check the results. So I will go to the beam diagrams. I will select the stage 5 and see the dead load results. And I click apply. So here you can see the legend as well. What is the maximum sagging and the hogging moment. In case I want to see results only for my steel girder, so I'll just select that and I will activate them. To check the results for the stress diagram, we go to the stresses and here I will choose the beam stress diagram. We get the stresses part wise. So I check the part 1, that is the girder, and I see stress corresponding to the same. Part 2 will be the deck, and you get the values like this. Then we can check the results for deformations as well. So I go to the deformation and I choose displacement contour. So if I update the units here, you will see the values has been updated correspondingly. So the conversion of units is always a flexible thing in the MIDAS Civil program. Once done with this, we can check the results for the moving load. So for that, I will go to the post-processing mode. And here I can select the forces as beam diagrams. Click apply. Basically, we are selecting the component and the load case and then seeing the results. I just update the units back to feet and I just activate the steel girder. Once that is done, you can see the results and it will show you the maximum and minimum element as well. So the maximum is element 487. To check the position of the vehicle that is causing this maximum moment on your bridge, we are having the options of moving tracer. So we just go and select this beam forces moments in the moving tracer. I will give the element number as 487 and I hit apply. So program will give you the position of the vehicle that is causing the maximum moment for that bridge in this manner. So as you can compare, like this is the influence based analysis, like for each element influence line diagram is made. As you can see, like this is the ILD for the element 487 and then the vehicle is positioned corresponding to the same to give the maximum effect. Apart from that, now you have the incremental loading option available through the plugin which I already showed. Another thing is like to create the load combination under the results itself, you have the option over here. You can go to the type of design to be completed. In case you are doing composite steel girder design, I just select that. I use auto generation and here I will choose the code AstroLRFD and I click OK. So I have all the load combination for strength and serviceability with the corresponding factors. Now I just click close. Once you have performed the analysis and the results part, in case you want to use any images in the form of report, you can always right click and use that as the dynamic report image. So basically program will save it as a report image and you can easily import that to your Excel file or the Word file, which I'll be showing later in the presentation. Once we are done with this, we go to the design option. Under the design, you have the flexibility to choose what type of design you want to perform, whether it is steel, RC, PSC, or composite design. After selecting that, you choose the relevant code. So we have the updated code of Australia FD20, and same thing goes with the Canadian standard, that is updated one. And here I just give the details and then I can perform the design. Once we perform the design, you find another option for the design result report. Basically, after doing that, you will get a report which looks something like this. So you have the AstroLFD 2020 code and the details of your section. And then all the checks are made as per the code clauses. So you have the clauses and the checks are made and shown whether the check is satisfied or not. Now the important thing with this clause reference is that as we know, a lot of DOTs and states specify their own amendments on top of AstroLFD. In that case, it becomes quite complicated at times to understand how to perform the design. People usually do that manually since those are amendments. But here I will say another alternative is like say you perform the design for Australia FD in this manner, and then on the parallel side, you can just have your clauses written. And that can be linked using API as well to perform the iteration or to create an upgraded version of this report. So we will be soon launching that as well through the API, but that is another example I would like to highlight. Now, once you are done with all the report part, the next part comes the extraction of the result. So for that, I go to this apps option and here you will find this mappy key. So idea here is you can just copy this mapping key and you can just go to any Excel report in which you want to import the results. So I just go to this mapping key option. I paste it here and I click apply. And from here I choose connect. So you will see like it is connected. Now whatever images I have shaped in the form of dynamic report image, that can be easily imported in my sheet. So this can be your general sheet that you usually use to create the report submission or something like that, like where you have model overview, results, deformation, tables, input info, and the design part. So it can be any specific report that you are using. But here you will find this MIDAS connector, which is an important thing. So when you go to this add-ins option, you go to this more add-ins, and under the store you can just search MIDAS, and now you will find this MIDAS connector, and you just have to click add. Once you add that, you will have this MIDAS connector in this format. First, as I already did, you will connect the API key in this manner, and then you have the option to import any table or the images. So I just go to this part and I'll be updating and importing all the images over here. So just click on all image, import and update, and the program will load the image in the desired location. So you get all the results images as well for all the construction stages in just a single go. The deformation, displacement contours as well. Now obviously you might have to import some result tables as well. So that can also be imported. So we just go to this result table and I will update that. So you see like the reactions and the deformations from my stage 1 has been copied in this fashion. Now this was done like suppose you have made the model one time in the program and you perform the design and you wanted to extract the results. Now another situation comes where you have to make some iterations to your model or you want to adjust some geometry or the layout. So we will be taking an example for the same using this geometry update feature sheet that I've made. So using this sheet, you can just connect the mapping key and again you can convert your geometry in form of any skew or the cross slope that you want to give. So as of now, you have seen like we were having the straight geometry for the bridge. There was no skew included, but now we'll be adding skew as well to our geometry in the same model. So basically here we just give the skew angle and then we click on update model. Before that, I will just set to make the model visible parallelly and use this plan view. I'll just save the file in the other folder or as skew file. And we are on the top view, so you can see like it is the straight file. And I just click on update model from here. Once I click that, you can see like the changes are made in my geometry in this manner. So now you can see earlier that was a straight program, but now it is a skewed bridge, which we just easily updated using this API key from the Excel VBA coding. Now I'll just perform the analysis of the same so that we can again see the updated results. By the time analysis is being done, let's go back to our Excel file and understand how this VBA coding is done. So basically, you will find this developer tab here. We just go back there and select this Visual Basic. In this Visual Basic file, you will find some modules which are made to update the geometry or like give the logic behind like how to make that. So basically API is a platform which is used to communicate to another platform just by requesting for some information and receiving them back. And then we can make some changes to that and then send it back to the used platform. So here you can see some modules as well that are used to convert the data in the JSON format, which is shown here. So this JSON converter is something like you can just copy and use it in any sheet that you are going to make. Then comes the main logic, which is the skew sheet over here. So this skew module, to explain it, basically a request is sent through VBA and then a response is received for the same. The response is received in JSON format, which is further converted to dictionary and then read by the VBA. And then we make any changes in the data and then it is converted back to JSON format and sent back to the program. So that is the whole process. Now here you can see like first the dimension and every details has been imported. So if I start from this part, like this is the dimension is made first as the dictionary, which I already mentioned, like the response is taken from JSON converter and it is converted to dictionary so that it can be read by the VBA. Then you have the logic behind like the response that has to be said. And we are having XYZ coordinates over here and we are saving it as double. Double means like the decimal values like integer up to two places that has been saved. Then here XYZ I'm having and we are making some changes to that. So this XYZ is converted to new XYZ and the values for those are calculated based on this equation. So x equal to x minus y multiplied by tangent, range and the skew angle. So that is how like skew is incorporated. We are basically calculated the new coordinates based on the skew angle which has been given. Once your data is modified and set, again you can see like it is converted to JSON format and then sent to the model. So that is the whole process. And at first it looks like something really new or like something really complex, but honestly, like you just have to deal with this much of logic. Apart from that, all these things can be easily copied and used for the other modules where the data is just converted in one form to the other. Now coming back to our program. So now it has been analyzed. Now to get the new results, like as we know, like we have changed the geometry, so all our images and the tables will be updated corresponding to the same. So earlier, in case you are creating any report manually, you have to edit all those data. Like you have to take new screenshot or like you have to export that again to your report file. But now that is made really simpler. That I'll be showing with the sheet that we made or we were using this MIDAS connector. So for that, we go back to this modular overview and I'll be just going to the result images and click all images, import and update. So you can see earlier that was a straight plan that we were having. Now you can see the skew angle being incorporated and under the results itself, you will see all the images is being updated. This is how easily you can make any changes to your model as well from the API itself sheet, and then you can export all the results corresponding to the same. Same thing goes for the tables as well. So if I click on result tables and I click all update, so you can see like this has been updated as per the new results. So by this example, we can see how easy it is now to make any changes in the bridge model as well and to obtain the post-processing results smoothly to your Excel file. With this, I conclude my part. And to summarize, we have talked about different plugins available. We have talked about MIDAS connector, which was used to import all the results easily to Excel from program. and easily update those results as well if the change has been made in the model. Then we also saw how to make any changes in the geometry using VBA coding. I hope you enjoyed the demonstration of Civil NX and are excited to try at your end. I'll hand over the mic back to Edgar to talk about our services. Thank you again.
Right? Now going into the final part of this presentation. For the people that joined a bit late, we have a QR code available in case that you want more information about this MIDAS collection, information about the different tools that we have presented today, or for general info if you want us to provide to you. You can quickly fill out, scan this QR code, put in your name, and we'll be able to contact you right away. Also, we are sending the link via our chat box, so you can also click on your computer and fill out the form. Last part of this presentation is the different versions of the MIDAS collection. Just for your information, we have three versions of MIDAS collection package: Essential, Premium, and the Ultimate version. I'm gonna break it down for you. The Essential version includes the Civil NX, and it includes the API capabilities as well as the movie load analysis, static and dynamic analysis, up to 10 construction stages. The premium version includes all of the essential version functionalities, unlimited construction sequencing, segmental cable bridges, as well as dynamic nonlinear analysis, the general section designer, and the composite girder module design, which includes the modeling wizards that we showed today, as well as the design code checks that we also showed. It also includes the pushover analysis for performance-based design. And then we have the ultimate version, which includes all the features of the premium version of Civil NX. It also includes the rail track analysis, material nonlinear analysis, heat of hydration, and also includes all of the features of FEA NX, including all of the geotechnical features, all of the features of MIDAS CIM and MIDAS CAD. This ultimate version includes all the packages, all the programs that we have presented today. Again, thank you all for your time and patience today. If you'd like more information or learn about the programs that we have presented, please scan the QR code and fill out the short form, and we will reach out to you as soon as possible.